Hey, how you going? I'm gonna go into a uh, program made by me, like custom program, like a variant of a program, a kind of textbook program you make, for like system software, as you can see here, or computer science. It's kind of that, kind of stuff like that. It's a well-known problem, been around for a long time, probably since the 80s, 70s, maybe 60s or something. It's got to do with multitasking. So um so different processes running at different times and stuff like that. So one process will run. Uh, so how you have multiple cores, multiple threads, stuff along those lines. But if you had just one core, um, you'd have multiple processes, and when one process, so if two processes are running on your system, but one is doing an I/O request, or in other words, uh, transferring files from hard drive to RAM or something, the CPU can't do that, so that process will order the transfer to the direct memory access controller. At least in modern times, and that process will enter the block state, I think, uh, or something along those lines. Either way, that process will just sit idle, and then the next process will load, and it'll start using the CPU. That's what this stuff is about. And in reference to this, uh, in reference to this, this is about two threads. One is a producer, one is a consumer. So this is the producer thread. This is the consumer thread. Sorry, I'm just drinking a cup of coffee right now. Okay, so you got two threads. Producer, consumer. While true, that means basically just do it forever, with no condition, unless possibly if you define true to be false, or I don't know, it's something weird or something like that. So you got a char character array that takes chars, and a char is a letter, A, B, C, all the way to Z. Main. Yeah, this is your regular main heading, so this is the entry point of the program. Firstly, it writes console write line. This is C#. System writes new line, next line, new line. This is syntax, or some special code. So when a write line subroutine or whatever writes something, when it hits this, go to the next line. It's also called carriage return. Carriage return it's like a typewriter. When it gets to here, you go carriage return. It'll go back to here because the speech things are not included after that. And there's also there's two of them. There's carriage return and there's next line or something. I'm not line feed actually. That's what it is line feed. I think we'll go to the next line. Carriage return will bring it all the way back. New line, this code here, will do both those things at once. I think you still can do character return, carriage return, but that'll overwrite. But That might be some low-level stuff or something along those lines. Then once again in C#, yeah, and okay. Last time before this semester, I was doing just C, just straight C. So yeah, everything looks a little different, but it's pretty similar. So console read key, that'll read a key, read one key. So you got the entry point. While console key available. Okay, yep, that'll come into play later. So you got console read key. That console read key will probably wait for you to press a key. So it'll write this. When the program is executed, it'll write this. After that, it'll wait for a key. Control Z. Once you get here, I think if you put something in that read key, the key that's read when you press enter, or return, you know, that's pretty obvious. When you press that, if you put something there like kind of you do something, this is just doodling really, char. And I have been on holiday for about a month, so char AB, yeah, I think equals null or some shit, and then you go some stuff, sorry, whoops. Okay, yeah, you do that. Char to ball, huh? Okay, but something like that, you can look it up on Lynda is actually quite good. It's paid, but I get it free through the university. So Lynda's very good, and yeah, I'm not being paid by them or anything. But in the case of C#, and I like C#. When I got a question about C#, like the syntax, all you got to do is, you know, open up your preferred internet browser, go to msdn.net and look it up. That's you can go to Stack Overflow, really whatever floats your boat. Doesn't bother me in the slightest, but my preferred method is MSDN. And also when I was doing Java, my preferred method was for looking up the syntax or subroutine or program or method, whatever you like to call it, was going straight to oracle.com, the documentation. I'm not really a big fan of Stack Overflow, but that's just my personal opinion, and if you've got a problem with that, then I've got a problem with your personal opinion as well. So what are we doing now? We got thread. So it'll write this, it'll read a key, then you got thread. So this thread, what it'll do is it'll grab this thread and it will turn it into a new thread, something along the lines of RAM, and then it will start it. Pardon me. So, okay, maybe it won't start it, it'll start it here. So when you press enter, it'll start the producer thread, it'll start the consumer thread, and these will both work. And the thing with this program is you got a one buffer. So you got one big buffer here, which is this. This is a char array or array of chars. It's called global char buffer. And what this will do is it'll take characters or chars, anything from A to Z, and it'll put it in this buffer. And the producer will do that. Then you have the consumer, and the consumer thread or process. I mean, it's a thread here, but as it's being explained generally by one's professor or something, it'll be consumed by this task, process, or in this instance, thread. There's a difference between all three, but that's not the topic of conversation right now. So you got the producer thread and the consumer thread. Just looking at the time, we're 10 minutes in. So you got producer, consumer. So producer will run. It'll run forever because while true. So that means basically while true, you could write something along the lines of you could do something like this. Int f equals 9. So you do that, and then you go while f is equal to 9. So as that, say what? Okay. I think I get it. Just take that, Control X. Okay, so while f equals 9, so what this does is int f, and it sets it at 9. While the variable that's stored in f is 9, this will run while. But if you put this, if you said f, so you don't need to declare it again. So you don't write int. That'd cause a couple of errors actually. So f set or equals 1. Let's go 18. Okay, so what'll happen is f will be declared at 9. While f is equal to 9, it'll do what's in here. And actually that would never reach there because this would go while f is 9, go down like this, and f would still be 9. It would go back to here or here and keep going. So you'd have to put that, Control X, there. So this would run once in this instance because f would be 18. It would go f is not 9, it's 18, and it would go to here and probably just be complete. Yeah, I don't mind C# and I don't mind Visual Studio, but it does have its quirks. So you got producer. So for int I equals O, I is less than 10, I plus plus. So that's a for loop. I equals O. Start I is set at O, I is less than 10, so it'll run until it reaches. It'll run till the end of 9. It won't get to 10 unless you put a equals or something into it. And every time it's run, it'll increment I. If global child buffer, okay, so that for loop go in this instance, this program that I made. I mean, everyone's program is different. This will go through. What that'll do is it'll have a look at global child buffer using the number for I to read which position. So it'll go 0 to 9. So it'll look at every element in the array, and if that element is empty, it will if the element is empty in this program, which is once again unique, or relatively unique. Global char buffer I equals console read key. If it's empty, it'll wait on a read key. So when the program comes up, you press a button or you press a character, and it'll store it in whichever element the for loop is on. Then it'll write line. This is debug stuff. You could do something like this if you wanted. So you could do that, but you would have to have something weird, and it wouldn't be in this position. But you go you do something like that, and then you could access this with some sort of code or something, or key command. If okay, so console write line location. So the location in which element. So it'll write location I, which where you were in the for loop, char, and then it'll tell you what it is. So it'll read it back to you in a way. And then while console key available, console will read key. This is a safety kind of protection kind of mechanism, I think. So while console key available, console read key false. Okay, I think that's the best I could find on the internet. So what I'll do is it'll take the char. Understand that this goes ridiculously fast. I mean, a couple of nanoseconds. You couldn't even if you just mashed the keyboard, you probably couldn't enter enough characters to reach the next iteration of the for loop in time. So while console key available, console read key false. So if there is another character in the buffer being read into the buffer, then it'll just ignore it essentially. So now you have the next thread, process tasks, etc. And these two threads, as they're threads, and as they're set here, they'll run concurrently. So consumer, while true, same type of stuff. Byte buffer active equals O. Not entirely sure what that does. So for int I, so iteration of 10, and it'll be using the same buffer. That's the thing with this program. This program uses a common buffer between threads, and that's the whole point of it. What it does, it's because you got things like deadlocks and stuff when you're running multiple tasks on the one processor and stuff like that. So you got errors. It's a whole kind of computer science subject. So byte buffer active. Not entirely sure what that does quite yet. I mean, I sat the exam for this couple of weeks / months back now, but so if global char buffer I, so if it is not Okay, yep. So this is the consumer thread. So it'll start at O. So when this loop is at O, and after it's been done once, it'll go to 1. So when it's O, it'll be accessing this. When it's 1, it'll be accessing this, so on all the way to 9, as there's 10. But the thing you got to remember is, so if you said, I have $0 kind of a thing, then you have no dollars. But if you were a machine in this instance, and you said, I definitely have $0, then in a weird way you would have something. So that's kind of binary and stuff like that. So location O in this instance is a location. That's all you got to remember. And there's 10. So you've got human readable, which is 10 locations. But here, 0 is something. So it's good to remember that. If global child buffer element not equal to, so if global child buffer is not equal to empty, global child buffer equals char 2 upper. So oh yeah, I get it. So it'll take the char, okay, it'll global child buffer char 2 upper, global child buffer I. So pardon me once again. Global char buffer element char 2 upper. Okay, so what's in there if it's not empty? Then, and if it's not empty, there'll be a character in there. So it's pretty black and white in that regard. So it'll take the character, it'll turn it to upper. So this is uppercase. So if you write a P, it'll turn it into that. That's what that'll do. Buffer active. What does buffer active do? Of course. Okay. So buffer, yeah, I know what it does. It buffer active is to do with remaining chars. So in the console write line, it'll tell you how many chars are remaining, and I wrote it in buffer active. This version of writing variables is known as Pascal as well. It's just, I don't know, my kind of thing. So you got buffer active O. I mean, yeah. Whatever. Okay, so this is going to be a new for loop. So this is ij. So you got buffer active. I mean, there's also, I'll go into it. There's also camel case. And there's also a collection of others. You've got stuff like that. You can go like that if you want. I think the original inventors of C did it like that. You've got a lot of other naming conventions. The only real important thing is universality kind of a thing. So you've got buffer active O and universality. What I mean is keeping consistent throughout the program. I mean, everything, whichever standard you use, you must use that standard through the whole process. And as you write bigger programs, such as my game, you start to really understand that you have to kind of be universal in what you're doing. You have to keep whatever you do. Well, what I realized in the game when making the game was I needed like kind of rules as to how it would all go. Like Do I put certain things in the main program? Like if it fits a category, it goes in the main program, and that doesn't change. Through the game, you have to keep doing. You have to follow the rules you made for yourself. So, buffer active. We'll go into that. Right line buffer char. Okay, if global char buffer j is not equal to. That could be done better, honestly. But I think this is very kind of, in a way, frenetic kind of thing. Like, it's very expanded, it's very human readable, even though it's code. So, this is the J loop, and it's inside an I loop. Okay, so it'll go to global child buffer. Okay, so what it'll do is it'll get I. So that'll start off as a 0, and it'll refer to that. So 0. Global child buffer is 0 if it's not equal to nothing. To upper it, buffer active equals O. Very interesting. For in C#, you should probably turn that to an int. I mean, even though you think byte is better, and by all means byte should be better, it's certainly more sensible and all that. I suspect, I'm not sure, I don't know, nothing to really support, what I'm saying, like, kind of evidence fashion, but I think C# just wants to use ints. I don't know. I mean, maybe I'm wrong. I don't know. But either way, that's what I've kind of noticed. I think you're better off just using int for everything. Don't know why, but I think Visual Studio just likes that. So in J, if global child buffer of J. So what is J doing? So you got int J. Oh, of course. Oh, yeah, I know what that's doing. That's pretty cool. Okay, so global child buffer. So it'll get one element, 0, let's say. If it's not equal to nothing, so if it's filled, it'll 2-upper it. Buffer active will be set back to 0. I'm not entirely sure if that's necessary, and then it'll go through all of them. So while it's accessing element O, it'll access every element in a different for loop. It will count them. So it'll count how many are not empty in total. Huh. Yeah, and then it'll -1. So it'll do that and write remaining chars, how many it found, -1. So you got console write line, buffer char process, location, the element that is in I, because that's the element that it's accessing, char, what's in it. So by that time it would be uppercase. Remaining chars, buffer active -1, global char buffer I, the one it's accessing, and set it to empty. Thread sleep, random next 400 to 1000 milliseconds. So 1000 milliseconds is a second. 400 is 4/10 of a second. So that's what it'll do. So let's boot it up. So as I was saying earlier, sorry, it will wait for read key, usually read key, what it does is it takes the key. So if you press O, when you press enter, it'll take that O and it'll put it where you write it, blah, 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 to put it. So, don't know what's with that. So the thread should be started by now. So where are we? Yep. ED. I don't know what's going on. Let's go R, location R. So, oh, that's very interesting. So, in a way, it's, what's it doing? Console read key. Global char equals console read key, keychar, read key. What's keychar? Yeah, read key dot keychar. You should probably look up what keychar is. I mean, I like C#, I'm good at it, but in certain ways I prefer C++ or C. It doesn't really matter. But I think they're somewhat interchangeable. You got C, which is just nice and easy. At least for me. I mean, some people prefer the high level stuff. I don't. You know, you get all sorts of things. I mean, only certain people can be taxi drivers. Really, it's weird. Like, not everyone's the same. Global char buffer. Okay, I'm not sure what keychar does, but either way, it's reading in something. It's not waiting for enter for some reason or another. Console write line, which would be somewhere in this line. So, okay, so global char buffer, so it's on element, well, 2 right now, which is the third element. It will be that. Global char buffer, and so that array at that position will the character that is put there will be console read key function or method dot keychar. Can't remember what keychar does, but whatever happens when you put Y, it takes it, puts it in the char buffer. Then the next for loop runs. So so what I'll do is buffer char process location 1 char R. So it's being processed. So this is the line that refers to the consumer. This is the line that refers to the producer. So I will enter M. Okay, it'll grab that M. Element 3, so 0, 1, 2, 3. This is now an M. And the concurrent thread consumer refers to this. So buffer char process location 3, char M, that's what it is, remaining chars 0. So they run. But because of this, the threads sleep. So because of sleep, you can basically hack away, kind of a thing. And as I said, there are safeties such as, see, this is happening between 1 second and a 4/10 of a second. So that's how that's working. So you go like that. Yep. So that's how that works. And oh yep, so this, as you can see, NJK, FJ, HK, N, and then you've got JK. Okay, so I think what's happening is global char buffer. Yeah, that's not really important. Yeah, so because of the delay, that's why you get that's why everything's not instantly processed. So if there wasn't the delay, you wouldn't have stuff like this. The whole thing would look like that, because every time you produce something, it would be consumed. So that's about it, really. Yeah, I think that about ends it. Thanks for listening. See you around.